Hello? All right, you can hear me? Yeah. Cool. Anybody on security here? Oh, man. I, I caught you before. Okay, I'm the least data person that's going to talk today. And if you have data questions, I try to answer, but it might be wrong. So, a little bit about me. Before me, that's a free book right there for Apache Iceberg, the definitive guide. If you want to take a picture of it and then use the QR code, I'm going to leave it there for a while. It's written by my boss, top boss, I guess, the co-founder Tomer and Alex Merced. If you worked on Iceberg, you probably read one article at least from him. And he's the guy actually who pushed me into this. This is awesome. Some more. What kind of QR code reader you're using? It took forever. Just kidding. Right. Also, another one, good blog where I don't write there. I think Alex writes way more than I do. Again, like I said, I'm the least data guy here. But then who am I? The name is Emre. I've been in security too long, over 25 years, and I'm the Chief Information Security Officer for Dremio, and a bunch of titles there, but the end is like I'm the security guy, right? So that's kind of what I want to talk about a little bit, like the security side of the world, because believe it or not, all the hackers are not after systems, they're after your data, the data that you guys are managing. They couldn't care less about the systems. Well, unless they're mining Bitcoin and stuff, but that's a different thing. You know that, right? Okay, cool. I want to talk a little bit about layers of access, what that means from a security perspective. Not like from a data perspective, you know this way better than I do, but from a security perspective, let's a little bit talk about which layers do we have in the security, like when I design a security system, which layers I look at it and which layers I want to protect and kind of like you should protect. I'm using all AWS stuff here, but this is, you can take this out, you can put Azure, you can take this out, you can put GCP, whatever, it's pretty much the same. I just had to choose one, I chose AWS. This is a typical, like, from a security point of view, typical thing, right? Like, hey, Emre, here's the thing, go protect this, right? This is what I see. For me, the data is stored in an S3 bucket, could have been stored in anywhere, Minio, whatever, doesn't matter, right? And there's a VPC there, some engine that is going to read that, some ETL operations that's going to read that, some data, right? There are other data sources, and then there's a Lambda function that does some magic that somebody wrote in 2017, and you have no idea what it does, but it's there, right? So that's one of those, and then that's kind of the layers the storage layer, and then the engine layer, and then the account itself. And then you have many of those, right? Like you have the finance guys who have an AWS account, you have a, whatever, right? So that's kind of what it is. And I put some cute narwhals because that's our logo. I had to represent, right? So let's start with the file bucket layer, right? Like what can we do there? And think about, like, let's play a little bit of adversary in here. What's the adversary, like, who's your threat model? What's your threat model? What's your appetite for risk? Do you consider AWS as a threat? Do you trust them fully? Right? Like, is this a good starting point for you, or is it not? Right? Think about it that way. Does AWS take all your data that you store here and do something with it? Or somebody who lives in AWS they don't know about can actually get that data from there? Because that's where it all starts. That's where everything is stored, right? So depending on what your risk appetite is, what can you do about it, right? Like you can encrypt data at rest, right? And that kind of prevents someone walking into a hard drive, taking it out of there, going out, and then sell it on eBay, and then somebody finds your data right away. That's kind of what it is, mainly, when you're encrypted at rest. But so that's what you're preventing, actually, right? Or you're really not preventing AWS reading that data, because guess what? AWS is encrypting that data. So now that's your trust base. If you don't trust AWS, if you don't trust their encryption, you don't trust their encryption, you don't trust their key, you don't trust it. That's trust has to start somewhere, right? But the good thing is you have options. You can do KMS, which is customer managed keys for S3. Well, that means, hey, here's my key. Just use it to encrypt it. But then again, you're giving the adversary again. Like if you think AWS is your threat, which I don't, but then that's also goes away. You cannot do KMS anymore. Well, there's I didn't put it in there, but you can actually store, encrypt it, and then store it. Right? Then you can encrypt it offline, hopefully not in an EC2 bucket. But if you don't trust AWS, that's gone too, right? Then again, what I'm trying to tell you here is you have options depending on your risk appetite. You trust AWS, you trust their key. Go ahead and encrypt it. Somebody's going to walk out with the hard drive and they won't have a decrypted data. They don't have clear text, so that's great, right? But if you don't trust AWS, then there are options. You can actually encrypt it offline and then store it in there. But how are you going to read it? That's a different story, right? Again, restrict access to S3 buckets using IAM policies. That's kind of big, and that's where a lot of leaks happen. And I'm going to talk about a little bit leaks, what happened before, which will happen again. Job security, and then if you're not comfortable with IAM policies, go ahead and read them, and that gives you a lot of control over your reading, writing, who can read it, which role can read it, which role can write it, which role can delete it, right? This type of access, and which role can read the bucket, the entire thing, how you design them, and be comfortable with them. But however, that's not but wait, there's more, right? There's always that. You can use control. You can actually control network access to your S3 buckets by using VPC endpoints. What does that mean? Anybody know what VPC endpoint is? So yeah, and VPC endpoint is basically that cute logo right there. This is depending on your policy, of course. You can actually tie the S3 bucket to a VPC, right, or a something, whatever that principle is. So which means even if you screw up the bucket policy, it's not going to be open to the world. And us security people love to design things like an onion, right? Like one security control on top of another security control. So think about it that way. Like you have the IAM policy. Maybe we should put a VPC endpoint because only this VPC is going to read this bucket, right? And it's pretty easy to get lost after that. But still, it's good. Some logging and monitoring is, I think, essentials. If not for security, it's good for cost, right? So, and then some S3 object log to prevent accidental malicious deletion of existing objects. Right? So that also, I find it like, it's saved, once you see logs, it's object log, I can't delete it. Well, maybe there's some bad guy is trying to delete it, but they don't know that you have an object log there. It's a good detection engine there. Signal. All right, so let's talk a little bit about S3 data leaks. It happened before, it's going to happen again. It's going to happen less, but it's still going to happen. So in 2017, Verizon data leak exposed 6 million users' data because of the misconfigured S3 bucket. And then it happens, but if they had maybe a VPC endpoint, right, maybe they were just accessing from that VPC, they still wouldn't have that exposed, even if they opened it to the world in the bucket policy, right? So it's a different layer that was protecting it. 2017, Time Warner exposed. I'm not here to shame companies, just examples. Time Warner exposed, these links, they go to their explanation, not some media article. I hate that. Time Warner exposed 600 gigabytes of customer data, including email addresses and account information. 600 gigabyte is big especially for 2017, right? Capital One data breach was an interesting one. They exposed 106 million customers. Some interesting data there. Go ahead and search for it. And if you're a Capital One customer, you go ahead and search for it. Okay, especially. There was a misconfigured firewall which exposed the S3 bucket. I don't know how you protect S3 bucket with a firewall. That's bullshit, in my opinion. That's explanation. Sorry, but like maybe they were trying to say VPC endpoint was configured wrong or something like that. But there's no firewall that protects S3 bucket. Period. So, 2020 Twilio exposed 885 gigabyte. It's kind of growing, right? The size of things, phone numbers, message transcripts. This is an interesting one. Does anybody know this incident at all, or have you ever heard of it, the Twilio one? They were serving a JavaScript file from that bucket that was compromised, and the attacker actually modified the JavaScript so that now the JavaScript was pulled by every Twilio client out there, which was awesome, isn't it? That's where I would put my exploit. So, because you trust that JavaScript is served by Twilio, but the S3 bucket that is serving it is compromised. So what do you do now? Think about it. Yeah. So these are some real world examples. I just, I didn't have a hard time to find for. Let me put it this way. There's a ton of them. There's Pegasus Airlines that lost, I think, millions of data, et cetera, et cetera. There's a lot of them. From S3, just S3. Remember, we're on just base layer now. Now let's talk about more. Well, what about the infrastructure? Right? What's the let's talk about a little bit like the top part of it. This is a lot of data leaks happen here too. What do we have here? Like dragons live here, right? What is it? There's a network there. Nobody knows how network works, right? So network, the packets go, come back, and I don't know how it works. I do. I spend half of my life as a network engineer, but still, there's a lot of empty knowledge there, which is thanks to cloud infrastructure. It's super easy. Everybody's a network guru now because you can click a button and then create a VPC and then a network and a gateway and But actually, what's going on under? Again, depends on your risk appetite. Do you trust the network that AWS provides you, right? Like again, where does your trust start? And then you go after. Like I trust it, but do you trust the other workload that is running next to you? Whose workload is that? Can they tap into network? Can they see my traffic? Can they? Did somebody enable the, I don't know, the network like packet collection somewhere? An admin did that, etc. There's a lot of like threats there, and also like there's a bunch of traditional compute stuff there, right? Like, are they open to the internet? Is it running a Hadoop that is like, I don't know, 5 years old? I'm not looking at you. Yeah, right. So, and then do we have a did somebody did support people install the Hadoop instance that matched the customer's Hadoop instance, and then they left it at the default passwords, and now what? Like they're on the internet. I'll give you 5 minutes for them to find it. Takes literally 5 minutes. Out of all these internet, the moment you open a port, it takes 5 minutes for them to come. Just let you know. Okay. BI tools are there, connectors, Lambda functions. Is your Lambda function like secure? Is it, again, like what's your adversary? Is it writing something on, because Lambda, up until like recently, it was running on AWS side of the world, right? Over the fence. So when you do that, and if you have like, I don't know, your private key, and you give it to Lambda function that actually would traverse your organization or your AWS account, it was running on AWS premises. What if it crashes? Does it take a crash dump? Is your private key there now forever? Who cleans up after that? Et cetera, et cetera, et cetera. Can somebody make it crash, and then some malicious guy can actually crash a Lambda function and then read that? Or like, there's a bunch of different interesting challenges there, and yeah, and they're all security controls, but that will take another 2-3 like sessions of me talking here, but just a couple of examples. There are other data sources that might not be yours, right? Like, and then you have some sort of like thing in mind, and it's great, and it's working, and it's compromised. Now, not only they have access to yours, and then maybe there's a path here to this finance database, whatever that is, right? You don't even know, or you don't. Depends, right? So again, like, that's not yours. Some random guy spun up something, and then that got compromised. And then if you don't have like security walls around it, like security groups and stuff, now you're compromised because again, like it will take them one port scan to find what is out there, and then they're gonna start trying. Hopefully, you have some sort of detections in between, like oh my God, it's compromised. We got to do some action. Let's shut it down, etc., etc. Or you can jail your workloads. These are the bored people. They don't like security, so they're leaving. Just kidding. Like, can you do like isolation through VPC? Can you do isolation through AWS account? Can you do isolation via security groups, etc., etc.? So here are some tools for this. See, I learned how to click now. You click here. Yeah, it's working now. Great. Segmentation. I love segmentation because segmentation is like super straight boundary. Like thou shall not pass, right? That's the moment where Gandalf is like, okay, I'm a Lord of the Rings geek. All right, I'll just shut up. Groups, security groups. I think, especially if you have a Terraform environment, please. I mean, this is perfect. Like you just define once and you're done. You're never ever gonna touch it again. It's not like you spin up an instance of what was my security group. It's not that. Like if you're Terraform, perfect isolation right there with security groups. I mean, again, this is AWS, but Azure or whatever, GCP, Oracle Cloud, I have no idea how it works. But yeah, I mean, those all have their counterparts, right? Workload isolation, data source isolation, access to the data source isolation, like this workload can do this one with this type of access, and that one can come to the same one with a different level access. It gets complicated, but that's again, what's your adversary, right? Like what's your threat level? What's your risk level that you can accept in there? AWS account level isolation. Some of my customers are like, no, Dremio, you have your own AWS account. You're gonna connect to my data sources from there. I don't want you to near any of my. Some of them are like, yeah, sure, right next to the data source, depending on their risk appetite, your risk appetite. Again, external party security is an interesting one. Like, you have a ton of interaction with GitHub. What do you put there? Do you put AWS keys? Do you put access keys? Do you put tokens, personal access tokens? Once you put it in there, then all of a sudden, like, it's in a different threat level. If the repo is public, it's public. Oh my God, right? It's gone. And then if you change it, it's in the commit. How many commits can you go back and then like do it? Like find it over there. Trufflehog finds it like this, right? So it's a tool to find the credentials committed in the GitHub. Yeah, so let's talk about real life stuff. Cloud infrastructure breaches. Now it's a different type of breach. 2022 or 2024, we don't know very well. Toyota didn't do a good job. You can click on it. There was a cloud misconfiguration, whatever that was, and then we don't know, of course. And then that exposed the backup server. And then they got into the backup server. What does backup do? It backs up data. Now you don't need access to S3 bucket because it's there. Every version is there. So if I'm a hacker, let's say I'm not a hacker, but I'm a bad guy, I would plunder your backup servers like this because there's every type of version in there. That's where I would go, right? 2022, this is an interesting one. Cosmos DB vulnerability. This was Jupyter Notebook related vulnerability. And this was giving unauthorized data access to like Jupyter instances and from Jupyter instances to backend Cosmos DB, which was a bug, and they had to patch it. I'm sure their security operations center was burning that day. 2019, this I love this one. Imperva. Do you know what Imperva does? It's a security tool. They do web application firewall. What they did is that one of their AWS compute instance was compromised. Remember, if you go back to one of these were compromised, or these, right? And then what happened? They got an AWS key inside the server because that's where you commit your that's why they have to access, right? That's how you access most of the tools. And then they got the key from there, and they went and plundered their backend database from using that access key. So again, this is why I'm telling you all of this is because this is another layer that you have to think about when securing a workload or an infrastructure, a data infrastructure, or any infrastructure. It doesn't matter. That's why I'm not a data guy. I'm security guy. Like I have to today secure a data infrastructure. Tomorrow I get to secure, I don't know, web application, right? So that's kind of how I look into these things. Let's talk a little bit about catalog layer, which is the weakest part of me, I must admit. And that guy knows way more catalog than I do. So the trend is, at least we're trying to push the trend to control in one place all these access to all these different places that you have in an Iceberg catalog. What's the good thing about it? Well, it's centralized. There's one place where you're gonna define this, and then you have different sources, and then that's where the catalog is gonna give you that whatever you want to do, right? And then namespace organization, right? They have the logical grouping of these, and then now you can logically give access to a group, something, right? Like maybe Counter's access and versus Emre's access to some logical groups are different, but they still have that logical group, right? Back, I love that word because that's the hardest part of any solution, in my opinion. Authorization is the hardest one. Authentication, solved problem. Authorization, we're still happening, right? And then yeah, you can define roles, you can define permissions, you can define users, of course, and then who has that role that has that permission, right? That's that cascading thing. And then you can do advanced catalog support cell level access, right? Like what do you? I had to deal with this like totally different data, like at Salesforce, for example. I had to deal with like bunch of cell level access to things, like, but it's not evident in the. And once the data is very clearly defined what it is, it's easy. When it's not that easy, right? This one is an interesting one because I want to talk to. This is the most iceberg thing I'm going to talk today, right? So I want to a little bit talk about what credential vending is, which is an interesting concept for me, and I've been working with Nessie guys a ton and Polaris guys a ton on this. This is in the middle. You have a run-of-the-mill Iceberg client, whatever you want to do it, right? And of course, you should support credential vending. And then we have a REST catalog, which could be Nessie, Polaris. For now, like I choose those two because I'm kind of always working with them. I'm biased. Everybody is. S3 bucket or GCS, wherever you store your data. ADLS is harder from this perspective, from an STS perspective. There's not like a super clear cut for this, but those two work really good with this model. So in this example, you're gonna select something from the table, right? This is by the extent of MySQL, right? So I know there's a star here, somewhere here, but I didn't put it. So, and then this one is the catalog actually looks from the table name or your namespace name, like where like do you have access to this? Because that's what you defined in the catalog, right? We were talking about one slide before, right? And then okay, it's like, and then the catalog reaches out to S3 bucket because they have some sort of like trust relationship between them, like via access key or some sort of role ownership. And then they generate a temporary credential for that IAM policy, right? For this person. Now, this could be a couple of things. It could be a signed URL. And are you familiar with signed URL, everybody? And then, or it could be a temporary token, right? It could be one type of token that is defined. Then the Iceberg client from that point on, right? And then they basically go ahead and use that token. Why do we put this now in the middle? Well, this is where, first of all, you enforce the access, right? And then the other thing is that the other important thing is that these credentials are short-lived. Well, short is an interesting thing. 5 seconds is a short thing. Sometimes 5 days is a short-lived credential, but it's way shorter than like forever credential, right? And then the catalogs knows how to rotate the credential that they handed to the client. They also know how to rotate the credentials that they have to generate those signed URLs and everything. So which gives you two levels of like security level that I like as a security person. Well, you might like or you might not like, because if you're managing client tokens, that's not fun, right? But as a security person, I like it because I don't have a forever token, right? I like this is like, let's say 5 days, and let's say this one is 5 hours. Now you have an exposure date of five days max, right? And that 5 days max is actually the worst credential, because that's the credential that allows you to create many credentials, which is that's the credential of credentials, which is I'm kind of like scared of it. So that's the part. Like depending on your appetite, you can do, I don't know, 3 hours of main credential that constantly repeat changing it, and then like 5 seconds of it. Depends on how much data access do you need, how fast do you need, et cetera, right? So that's, again, depending. A lot of security stuff is depending on your risk appetite, right? The important thing is having the tools. What else do I have? I have this step-by-step. I kind of went through it, but I'm not going to go do it again. But if you, are you guys going to publish the slides, or then you have it. There you go. Some links. I don't know what they are. Intro to Iceberg. Let me read it for you. For the guys at the back. Postgres to dashboard. I don't know what it is. SQL Server dashboard. MongoDB dashboard. I don't know. So, but they are good things. Alex gave them to me. They are good. I trust Alex. There's a podcast also. That's the Database podcast that we have. I think Tomer runs this. Tomer is a cool guy. Go ahead and listen to him. He has some really good guests. I was listening, although I'm not a data guy. I was listening it, yeah. Well, that's pretty much it. Any questions?
Any questions? We'll take like one or two.
So data catalog, I suppose it's a single point of failure now, and do you need to protect it even more, and can you sleep at night?
Yes, that's an excellent question. Security control is always a single point of failure, always. I mean, there are rare occasions that you don't have that, but that's when you design it layer by layer, right? So like from a security control perspective, yes, definitely. This is where you, like, is Okta your single sign-on? Is it single sign-on? Is a single point of failure? Yes, right? So, but also, like, which one is worse? Like managing in one place and rotating in one place and, you know, giving access in one place versus like 6 different places. And then well, I mean, I can go either way. I can explain the benefits of either way. Like if you have 6, if you lose one credential, you only 1/6 of your environment is exposed, right? But if you do it in one place, everything's exposed. So there's that. If you look at from that point of view, yeah, having 6 of them is better. But then how are you going to do credential management? How are you going to do rotation? How are you going to, et cetera, et cetera?
If everything is happening at the catalog level, like I as a client as a query engine, what is that I'm supposed to or expected to do?
Yeah, the question is if we are enforcing this on the catalog level, what the client needs to do, right? Iceberg client. Iceberg client needs to support, first of all, vending credentials. And I think I cannot name them, but I have it in my notes. But yeah, that's one thing that definitely needs to happen. And then I'm hoping that the standard is actually enforcing this. And then the other thing that I'm hoping is that you know how to, if your client token expired on the client, and then you actually re-request the client. So it's there's some sort of a retransmit logic that you have to do, unless it's a one-time thing, right? If it's a one-time thing, there's no problem.
Maybe for the lack of my knowledge, today with 2 query engines to the catalog, I authenticate and then connect, for instance, Iceberg with the blue catalog or something, or REST like I do it. So there's nothing that I do today in terms of, in this aspect of credentialing. So I'm just...
Yeah, that's kind of new, I think, yeah. And then that's the, Nessie is supporting that, Plur is supporting that, as far as I know. I'm biased, super biased on that. And then that's what it is. I think The other thing that I can tell you is from a like the Iceberg V 1.8 version 1.8 now has support for refresh credentials, right? From an OAuth perspective, though, not from vending credentials perspective, right? So I think since now once you know how to refresh credentials, the next thing is like it shouldn't be a problem to refresh vending credentials, right? So